My name's Eric Gray, and my colleague Tom Fenton and I have that responsibility at VMware as part of our competitive lab team. Today we're going to be talking about some of the things we've experienced hands-on in our lab. We'll be covering vSphere, of course, because we've got a lot of experience with that, and also Hyper-V, XenServer, and I'll talk a little bit about Red Hat Enterprise Virtualization. Now, I really want to encourage you to take this information and use it to do your own analysis, to find the best platform for your own environment. Hopefully, you can use some of these technical points that I'll mention as a foundation for your own investigation. But before I go into my own recommendations, let's take a look at a couple independent affirmations for vSphere that we've seen just recently. The first one is, at Microsoft's show called TechEd, I'm sure everyone's heard of it, vSphere was actually chosen by the attendees for Best of Show. So that tells you that, yes, Windows is a very important operating system in the data center, but people are running it on top of vSphere. vSphere is a great place to run your Windows applications. And secondly, I'd like to point out, if you haven't already seen this, Gartner published their Magic Quadrant for server virtualization, and vSphere is positioned in the Leaders Quadrant. Again, affirming that vSphere really is the best platform for virtualization. Today's agenda will be three areas. I'll start off with the core hypervisor, some about the footprint, configuration, upgrading, and then we'll move on to shared storage, a really critical part of your virtual environment. After that, I'll turn the session over to my colleague Tom, and he's going to go into resource management, talk about some availability and flexibility that vSphere offers that you won't find in some of the other platforms. So let's get started. When we talk about hypervisor footprint, what we really mean is there are two kinds of bare metal hypervisors. There's one that's purpose-built for that job, and there's the other that is based on a general-purpose operating system such as Windows or Linux, in the case of Hyper-V or XenServer. Now, if you go down that general-purpose operating system route, you're going to add many gigabytes of unnecessary code to your hypervisor. A smaller footprint, logically, has fewer things, fewer moving parts, fewer lines of code, fewer opportunities for security problems, for bugs, things like that. That's a really important thing to keep track of when you're choosing your hypervisor. Is it purpose-built, or is it based on a general-purpose operating system? The other thing I want to point out is some of the advantages that we get with the ESXi architecture. This is the stated future direction for vSphere. In the next version of vSphere, ESXi will be the only architecture available. ESXi is available in an image, but what exactly does that mean? Let's dig into it in a little bit more depth, and we'll get a little bit technical here in a moment. First of all, you got to know that ESXi is not based on an existing operating system. There's no Linux code in there anywhere. It's an image-based delivery. That means VMware produces this little package, just like you'd have on a router or some kind of other firmware device. You get that, you install it on your server. It's a whole image. And one of the advantages to that is everything's tested. The storage, the kernel, everything that's part of that package is what VMware QA'd. You're not adding additional driver updates to something that's already running. So you really have an advantage there. The second thing is you have this option for some redundancy. You can actually roll back, kind of like a server BIOS. So what I've flashed up here on the screen is an HP server. You've probably all seen this. Everybody probably knows there's an additional memory location for spare ROM. So if you do a BIOS upgrade and something went bad, you could roll back to that other version of the BIOS. So why not do that with your hypervisor? Why not treat your hypervisor just like that? And with ESXi, you can do it. If you're running version 4.0, you upgrade to 4.1, something's wrong with how it's compatible with your environment, you don't like it, you can go back to 4.0 with the press of a key during boot, and it'll roll right back. And then you can take your time and figure out what went wrong. Now, that's not something you can do if your hypervisor is based on a general-purpose operating system. So this sort of leads us to the question, if you've looked into the ESXi architecture, you probably know that it's very small. It's under 100 megs. But if you tried to install it, maybe you've noticed that VMware requires you to have a gigabyte of storage. So why does this tiny hypervisor need so much storage space? Well, part of it is to accommodate that rollback capability that I just described. As you can see on the screen, it's a shot from Linux partition editor looking at the hypervisor, whole hypervisor disk. So you have some partitions there. You have a little boot partition. You have two partitions for hypervisor. One's the active and one is the backup partition. They're 250 megs each, and they're just very partially filled. They're not full, but they're that big for future upgrade capabilities. Then there's a core dump partition and a utility partition. That utility partition contains ISO images so that you can install tools inside your guest operating system, things like that. In fact, most of that stuff is not needed. So as a little experiment, what I did recently is I took ESXi 4.0 and stripped it down, and I found a 64 meg flash drive, and I got it all on there, put it in a server, booted it up, ran virtual machines, everything is there. So it really is a small footprint, even though the disk requirements are a little bit more. And by the way, I have a blog. It's called vCritical. You can see the URL at the bottom of the screen there. And I have the recipe posted. If you were interested and thought it'd be a fun thing to do, some customers out there have tried to do the same thing and get ESXi to run off of a tiny little flash drive. So now that we've seen how the small footprint fits into your server architecture, it's also a great time to mention that ESXi can be run off of USB flash. And if you have some of the newer servers, like the ones on the screen, that's a shot from my camera phone in my data center. That's a HP BL460C. They have these SD card slots right in the top of the blade. You buy the particular SD card from HP, you pop it in there, you do your ESXi installation, you choose the flash device, install it, and then you're in business. You don't need any spinning hard drives. So that can save you money when you're buying your servers for your hypervisor hosts, and also save you a little bit of power because you don't have to run those hard drives. Once ESX is installed and up and running, it's very easy to get going because it's purpose-built for virtualization and not based on a general-purpose operating system. Everything's in there, ready to go. One thing such as NIC teaming, really easy to use. ESXi is designed for NIC teaming, for failover. You just add a couple physical NICs to a vSwitch, then you have redundancy for your virtual machines. You don't have to add third-party drivers like you do with Hyper-V. Yeah, Hyper-V has NIC teaming, and they say, well, as I like to say, it's not unsupported. It's supported, it's just not by Microsoft. So if you're going to use Microsoft Hyper-V and you want to do NIC teaming, you're going to have to talk to your NIC driver vendor because they're the ones who do the NIC teaming software. Another thing that really points out how ESX is designed for the data center is it has Cisco Discovery Protocol built in, CDP. You can see on the screenshot there, I know exactly which switch port on which switch these NICs are plugged into. So I don't have to go to the data center and trace cables around to figure out where I'm plugged in, make sure I have the right trunking set up on that particular port. It's designed to do what you need to do in your data center. After you have your host set up, the next thing that's really easy to do in ESXi is to build a cluster. It's designed for clustering because that's how you get the advantages of a virtual infrastructure. ESXi, with a few clicks, you build your cluster, you drag and drop your hosts in there. They're already configured, they're ready to go. Hyper-V HA, if you didn't already know this, is based on Windows failover clustering. That's the old Microsoft cluster server that you use for a database or Exchange server. They adapted it to use that for virtual machines. So if there's a failure, it can restart a machine on another host. But this is additional configuration using another interface, using other verification, other storage setup. It's much more time-consuming than ESX and vSphere. Secondly, that makes it easy, we have a single client that connects directly to a host, if you have a standalone host, or you connect the same vSphere client to a vCenter server, and you can manage an entire data center of hosts. Same interface, same terminology, same capabilities. So we make it easy. In fact, Hyper-V, Microsoft has this single pane of glass term they like to use, but it's really marketing hyperbole because they have so many utilities to get a Hyper-V environment up and running. In fact, I really got a kick out of this quote from Bob Muglia sometime last year. He's a president of the Server and Tools division at Microsoft, and he went on to say what you see on the screen there, essentially saying, vSphere customers can benefit from System Center. You can have a single pane of glass to manage all your Microsoft stuff and all your VMware stuff. So I said, wow, that sounds great. Let me go take a look at that. So I went in search of this single pane of glass. And I'm going to show you what I found. I found this. This is System Center Virtual Machine Manager. And it turns out that's not just a clever name, because, in fact, that's all it does. It manages virtual machines. If you need to create a VM, start and stop, migrate, this is your tool. If you need to add some storage to a host or a cluster or create a cluster, this is not your tool. It won't do any of those things. And, in fact, it won't connect to an individual host either. For that, you have another tool. It's called Hyper-V Manager. And there are a few things that Hyper-V Manager can do that the other tool won't do, so you probably need to use both from time to time. And by the way, they have some different terminology. One of them uses snapshots. The other one uses checkpoints. They're the exact same thing on the host. They're just developed by different teams at Microsoft. They're not synced up 100%. Of course, neither of those tools do any sort of performance monitoring of your hypervisor, and they're not purpose-built like vSphere is to monitor the important performance counters that are critical for monitoring your virtual environment. But you do have Operations Manager. That's what you see on the screen there. And it can do historical performance trending of what you can find in a Windows performance counter. But it doesn't do real-time performance counter very well like vSphere does. You have the option to do real-time or historical. So you'll probably need to use perfmon to get some of that data out. It's a separate tool, separate configuration setup. There's another diagram view if you want to drill down. Again, that's another window. When you're ready to set up, let's say, an iSCSI LUN to your hosts. Well, in the vSphere client, it's all part of that tool. Everything you need to manage virtualization is built into vSphere. With Microsoft, again, using the general purpose operating system tools. Same thing if you need to get some information about your fiber channel HBAs, your SAN. And if you ever needed a reminder as to why virtualization is so great, I encourage you to go out and set up a cluster of physical window hosts on a SAN. And you'll end up using all these tools, and you'll use this storage management tool, and you'll see, why do I have 4 or 16 different instances of this volume presented to me? Which is the path that I'm supposed to use? Because by default, multipath I/O is not enabled on the Windows host. You may have to download some tools from your SAN vendor, or enable the native MPIO using this other interface. And of course, once you do this, you require a reboot, so you'll be restarting your host. vSphere, on the other hand, is built to be on a SAN. It's built for MPIO. It's all enabled and ready to go by default. And once you're ready to build your cluster after you've configured your individual hosts, you need another tool. This is the Windows failover clustering tool. You'll go out, you'll set up storage, designate it for clustering. You'll cluster your hosts, create them using the Microsoft clustering technologies. And then last, if you want to try to do any patching, upgrading, anything like that, you're going to have to resort to another tool, possibly Configuration Manager, which in itself is a whole specialty, and it's probably not likely that a virtualization admin would be that well versed in using that tool to, say, perform a hypervisor upgrade. But it is a possibility. And you've probably heard of Server Core. Server Core has no GUI, has command line, so you can do some management using that tool over there. And this is great because now you can patch Internet Explorer on Server Core using command line, as you can see there on the screen. And what I mentioned earlier, here's the NIC teaming software. You've got the third-party drivers. So first step is go create your NIC team. Then you install Hyper-V, tell it to use these new teamed network adapters. And so I found out that actually the single pane of glass isn't software at all. It's the monitor sitting on top of your desk. Now, when it comes to upgrades, I say that's a sign of platform maturity. VMware Update Manager can coordinate an upgrade of an entire cluster of hosts in an orchestrated manner that doesn't require a lot of hands-on hand-holding. It's very simple. Once you've upgraded your infrastructure to vCenter, let's say we're going to go from 4.0 to 4.1. You update vCenter and Update Manager first. Then you upload the bundle for the hypervisor. You create a baseline. You specify the hosts. In this case, in the example on the screen, I have a 3-node cluster of ESX servers. And I tell it to go. And what happens is, one by one, a host is put into maintenance mode. The VMs are then evacuated automatically. The host is upgraded to the new version. It's rebooted. It comes back up. It's checked. It comes out of maintenance mode. Virtual machines migrate back onto that host using DRS. And the process repeats for the next host in the cluster. And it doesn't matter if you have 2, 3, 4, or up to the limit of the cluster. That can just go one host at a time and automatically upgrade your entire environment. Now, if we want to compare that to what customers had to go through if they're using a general purpose operating system for their hypervisor, in the case of Hyper-V, if you go from Hyper-V R1 to R2, you actually had no upgrade path at all if you're using clustering or high availability. The upgrade is sort of like this. There's a 9-step recipe you have to follow. You can get that off of Microsoft's website there. You simply evict some of the nodes from your cluster, blow them away, do a fresh install of the new version, and you're basically building a new cluster there, reconfiguring everything from scratch. You're shutting down your virtual machines. You're removing the snapshots because they're not going to be portable to the next version. You export it to another file, which can take some time, move them over, import them. It's a huge manual process. And that's because everything's based on all these general purpose operating system technologies, not purpose-built to do what needs to be done in your data center. And I'd just like to point out that over the past 2 years, back then, we were told that that was good enough for a lot of environments. So I don't agree with that. Perhaps it's good enough for some people. Now we're going to move on to storage. Storage is one of the most crucial areas of your virtual infrastructure. And vSphere gives you choice. You can use Fiber Channel, iSCSI, or NFS for your storage. And you can store virtual machines, templates, ISO images, all those things, wherever you like. And they're all presented in a similar manner to the virtual machines, so they're easy to administer once they're set up. Now, if you look at how some of the competing platforms really impose restrictions, if you look at Red Hat Enterprise Virtualization, for example, they claim support for all of those storage technologies, but they make you choose one technology for your entire data center and stick with it. So you have to choose, is this going to be a fiber channel data center or an iSCSI data center or an NFS data center? But if you didn't choose NFS, you're still going to have NFS because ISO images need to be on a NAS device and not fiber channel or block storage. So that's a serious limitation, and it limits your flexibility. Similarly, Hyper-V doesn't allow you to store virtual machines on a file server. You can only use block storage. But they require ISO images to be on a Windows file server share called the library. And it gets worse because when you deploy or when you try to hook up an ISO image to a virtual machine, it's not a shared environment like you'd see in vSphere if you're used to that. It actually makes a copy of that ISO, that DVD ISO that's 2, 3, 4 gigabytes, copies it over the network to the SAN where that virtual machine lives, and the virtual machine connects to a copy of the ISO. So that wastes network bandwidth, wastes space on your SAN, wastes time. With vSphere, you connect it up and go. One shared instance of the ISO image. vSphere is also the only platform with a true cluster file system, VMFS. That means we don't have a coordinator node in the cluster that's responsible for metadata updates. Two of our competing platforms have coordinator nodes or a storage pool manager in the case of Red Hat Enterprise Virtualization. Now with Hyper-V, cluster shared volumes require an additional dedicated network for that traffic because the hosts need to be able to talk to each other very quickly with good performance and reliability. And let me describe to you how this works. Let's say you have a Red Hat cluster and you're going to use thin provision disks. Well, if a host is not the storage pool manager, he doesn't have any ability to extend the volume. Okay, so if that virtual machine disk is about to run out of space, he needs to grow it very quickly. But he has to talk to another node in the cluster that's the storage pool manager. That is the guy that has to go out and extend the volume, and that has to all happen quickly enough so that there's no outage. If it doesn't happen fast enough, there will be an outage while the volume has to grow. And another problem with CSV, which is Microsoft's workaround to not having a cluster file system, is it's very hard to monitor with System Center. In fact, if you take a look at what those volumes look like in Operations Manager, they are all named with these very cryptic volume GUIDs. And it's impossible to quickly determine which volume is which if you need to address a storage, a low storage condition, something like that. We're used to having drive letters in Windows, but when you use CSV, you don't have drive letters. Now, vSphere VMs are encapsulated, and by that I mean there's a directory. Inside the directory is everything you need to know about that virtual machine. There's a configuration file, there's a disk, a few other things. You can move it around. If you had a catastrophic failure of a host, you could connect another host. You could quickly install a new one. It's very easy to do with ESXi. Point it at that LUN, register all the virtual machines on that LUN with a single line of Power CLI that I show up there on the screen. Now, there's no other platform that can do that. The other platforms bury their virtual machines down in these esoteric layouts. You'll see the Linux hypervisors such as XenServer and Red Hat use the LVM layout, and they create these very cryptic LVM, also named after GUIDs. Hyper-V, you have these XML files that it's not supported to edit them or move them around. It's impossible to take one of those and register it on another host like you may be accustomed to if you're using VMware virtualization. It's just not possible. If you had a failure like I described earlier, what you would have to do is take the VHD file, move it to your new host, and build a new virtual machine from scratch based on that VHD. So you'd have to remember, was that 2 CPUs? How much RAM was in there? What was the name of it? I don't know. So none of that stuff lives with the encapsulated VM. And when it comes to eliminating downtime in your storage environment, vSphere stands head and shoulders above the others. You can grow a VMFS volume right from the GUI. So the same vSphere client that we've been talking about all along has an interface to, once you've added disks, increase the LUN size on your backend storage, you can grow that volume, give your virtual disks more space. Now with Hyper-V, it is possible to grow a volume, but first of all, you have to figure out which node is the coordinator node, and then there's no GUI. You need to go to that coordinator node, log into it directly, and use a diskpart command line with certain commands to grow that volume. So it's possible, but it's not as easy to do, and it's more error prone. Okay, and then as far as extending your virtual disks for your virtual machines, vSphere is the only platform that allows you to add storage in that manner. You might hear Hyper-V, Microsoft claim that Hyper-V can add storage to a running virtual machine, but in fact what they're doing is they're adding an additional drive letter, okay, an additional hard drive. Now, if your application owner comes to you as a virtualization administrator and says, I need some more space for my application, it's running out, do you think they really want another drive letter so they can figure out how to span that data for their application across 2 different drive letters? No, they just want some more space. With vSphere, you can non-disruptively extend that disk, then go inside the guest, grow the file system, and everything happens with no downtime. And if you're using Red Hat Enterprise Virtualization, you can't even hot add a VHD or a virtual disk. You have to power it off and then add it. So you can't grow it, and you can't do anything if it's powered on. vSphere is the only platform with Storage vMotion. Storage vMotion gives you zero downtime migration of a virtual disk from one LUN to another. So it's perfect for migrating off an old storage array. Let's say you're leasing your storage array. Every few years you need to move. You can do that, no downtime. Let's say you have high-performance disks and lower-performance disks, and your workload requirements have changed. You can move those around without having to schedule a big outage to do that. And that's an exclusive feature found only in vSphere. And the last thing about shared storage I want to mention is a new feature in vSphere 4.1 that is really amazing. It's one thing to be able to prioritize storage access for an individual host, which, by the way, I'm not aware of other platforms that can even do that. But vSphere has been able to do that for quite a while. You could say this virtual machine is more important than this virtual machine. I'm going to give it more disk shares. It's going to have more opportunities to use the storage array. Okay? But what vSphere 4.1 adds is storage I/O control. Now you can prioritize virtual machine storage across an entire cluster. And this is really important because you might have one host that is not as heavy equipped. It just has one or two VMs on there, but those VMs are using the same shared storage as another host that maybe has more VMs, but those VMs are more important. These VMs that are more off on their own still get a lot of access time to that storage array, and they could actually interfere with the performance of those other more important VMs. Now with 4.1, you can set shares that are respected across the entire cluster. So if you have a VM that has twice as many shares, it's going to get more resources than the other one, even if they're running on different nodes. And this is a great foundation for building your private cloud, because you don't have to worry about the noisy neighbor effect when you're aggregating all of your resources in your data center and then subdividing them out to other business units and things like that. You can also throttle the IOPS as a new feature available there if you want to do it that way. Now, the other platforms don't have anything that can even touch this. And there was another session this week at VMworld, TA8288 that goes into this technology in great detail. So I encourage you to check that out if you're interested in that storage prioritization. Okay, I'll wrap it up here with some virtual disk. We've talked about the shared storage array, all that. As far as virtual disk goes, vSphere is great because we have fully supported thin provisioning. And it's the only platform that really claims thin provisioning performs on par with pre-allocated virtual disks. And not only that, vSphere fully accounts for the space you've used. So in thin provisioning, just as a refresher, maybe you have a virtual machine that really only needs 10 gigs of space. You go ahead and give it a 40 gig virtual disk so it can grow as needed without wasting all that space on your SAN right up front. The problem with that is if you have too many thin provision disks and they all suddenly have a great demand for storage, they're going to grow very quickly and fill up the underlying LUN. Now, vSphere can account for how much storage you've allocated, so you can do reporting on that, you can set alarms on that. But even if the LUN fills up, ESX is really designed to handle this condition and can quickly pause all your virtual machines that are affected while you address the problem by growing the storage, as we talked about earlier, or moving a VM off or something like that. Hyper-V, it's not recommended to use thin provisioning with Hyper-V because they don't have this accounting. You can't monitor in System Center how much space is actually being used by each virtual disk, only how much has been assigned to it. And they don't have the advanced crash prevention that we built into ESX. So if that underlying volume filled up due to a sudden demand for disk by many virtual machines, you would see guest operating systems crash as they suddenly have their disks yanked out from under them with no additional space to write. And XenServer, they don't have any thin provisioning on block storage. So if you're using Fibre Channel or iSCSI, they ask you to do that thin provisioning at the storage array level, which may be fine for you, but you need to make that decision. And isn't it good to know that you can do use the same administrative methodologies, whether you're using this protocol or that protocol? Well, that's vSphere. If you need that capability, you can only get it with vSphere. Now, similarly, we have snapshots. Snapshots are the ability to take a point in time of a virtual machine and be able to roll back to it. Okay, Hyper-V, they don't recommend using snapshots with Hyper-V because when you remove a snapshot in a Hyper-V VM, you have to power it off for it to actually go away. Even though the user interface will allow you to do that operation, it doesn't go away. It continues growing the snapshot file. And there are more than a few users out there who've been really bitten by that. They think they removed the snapshot, it's still growing, filling up their storage array. vSphere, we can remove the snapshot while the virtual machine is running, no problem. Red Hat Enterprise Virtualization has basically version 1.0 of snapshots. The VMs have to be powered off to do any snapshot operations, even to take a snapshot, and also then to restore it back. So it's very basic, and vSphere really shows its maturity in this area. All right, well, thank you for that, and I'm going to hand it over to my colleague Tom Fenton now, where he's going to go into some resource management and availability issues.
Great.
Thank you, Tom.
Thank you. I'll go ahead and talk about resource management. Thank you, Eric. Let's see. I need to be able to swipe it with some of that new technology that's out there. Resource management. Resource management is all about availability, control, and effective resource utilization. And not only will I talk a little bit about hardware utilization, but we'll also talk about one of the more interesting resources you guys get a chance to manage, and that's human beings. That's probably the most variable resource that's out there. So I'll talk about fault tolerance. I'll talk about affinity and, of course, anti-affinity. Role-based access control. This is about managing your users. Resource pools. And as the clouds become more ubiquitous, you're going to see where resource pools really are kind of the key to multi-tenancy and separating out different kind of groups and how you can take your resources and divide them equally or unequally, depending who has the money, to make sure they get shared. And then finally, memory overcommitment. And this is the one that I like best because we take a look at some of one of the other platforms out there and how they do memory overcommitment. It's real interesting how they chose to implement it and some of the limitations they put on you guys. Let's go ahead and get started with fault tolerance. Fault tolerance is really about zero downtime. What I mean by fault tolerance is you have two guests running kind of in lockstep with each other. When this one executes a code set, this one does it in the exact same time. And if this one, for some reason, goes down, this one can pick it up instantaneously and run with it. And this ensures that you're going to go ahead and have zero downtime, continuous availability, and your data center is going to run as you want it to run. And so let's take a look and see how to configure this. First, we'll take a look in vSphere, see how to configure it. It's real easy in vSphere. You simply bring up your vCenter, right-click on the guest, go ahead and say turn fault tolerance on. A little bit later, you'll get this little dialog box saying, hey, yeah, you want fault tolerance. We're going to have to convert your thin disk to thick disk. You say, yeah, that's a small price to pay. And a few minutes later, you're going to get a dialog that says, yep, this guest is protected. It is enabled and running. And it even gives you the location of the second guest that's running in lockstep with this. The first time I did this, set this up, is I had one of the engineers sitting there next to me. And I said, okay, so do I have to reset the host, the SX host? He goes, no, you don't have to reset the SX host. That kind of would defeat the purpose of having fault tolerance. Okay, so do I need to reboot the guest? He said, again, you're missing the point, Tom. This is about fault tolerance. They're both supposed to be up at the same time. So really, that's all there is to it. There are some preconditions you have to make sure, making sure you're running the same CPUs, things like that, but that's as easy as it is. VMware made it very simple to implement fault tolerance because we know it's important to you. So let's go ahead and take a look and see how to set it up in Hyper-V. It's real easy to set up in Hyper-V because they don't have it. And that's fair. Hyper-V's, still a little bit young. They haven't been around for a long time. So next one I decided to take a look at was XenServer. Had a XenServer set up. Said, let's go ahead and set it up in XenServer. Maybe see if they take a little bit longer to do the fault tolerance, the failover, things like that, right? And so I went to set it up, and they don't have it either. Oh, there we go. They don't have it either. And then a colleague pointed out to me and said, Tom, there is a third-party product out there that will let you do fault tolerance, that will let you use it. But that really isn't one of their core technologies. Oh, and by the way, you best be wanting to run it on Microsoft OSs because it doesn't support Linux. And it only supports a few of the Microsoft OSs. So I think on that one, we're going to have to give, in the shootout, if you're keeping track, VMware 1, the competition 0. The next thing I want to talk to you about is affinity and anti-affinity. And we'll talk about two different kinds of affinity and anti-affinity. The first one, you're probably familiar with it if you're a vSphere customer. And that's where you have two guests, and you want them to run together on the same machine. You might have a database and a web server. And because of the efficiencies you gain with the networking, because they're both on the same host, packets can fly very quickly between each other. So you want those running on the same host. However, if you have a primary and a secondary DNS server, probably don't want them to run on the same host because if one goes down, it could take down your entire infrastructure. So, affinity, anti-affinity. The new one that I want to talk to you about is called host affinity. And that's where you want a certain set of guests to only run on a certain set of hosts. So let's take a look at that. Quick review, actual use case. And the reason you want to do this, and when I first got this, I just didn't kind of understand what's the purpose of this host affinity. And he says, oh, Tom, my engineer friend said, some databases are licensed to the host. They aren't licensed to the guest. They're licensed to the host. So you want these guests only to run on certain hosts. So here we have my VMs. I'm going to create a group of them. I'm going to call this my database DRS group. Then here's my hosts. I'm going to take a group of these hosts that I do have licensed for my database. And I'm going to call it my database host DRS group. And so these guests are only going to run on these hosts so I don't violate my EULA and get in trouble with the lawyers, because no one likes to deal with lawyers. So who has this? This is called Host Affinity, and VMware 4.1, we introduced it. XenServer, Hyper-V, they don't have it. So again, if you're keeping track, VMware 2, competition 0. And I don't want to really spend the rest of the talk talking about things that we have that they don't have, because it might be boring for you. It'd be exciting for me, but it might be boring for you. So let's go ahead and talk about something that they do have. Like I said, one of the more interesting resources that you manage is users. Whether you like it or not, you got to give users the right roles to get their jobs done. And you don't want to give them any more roles than they have. So I'm going to take a scenario. I have a user here, and he's the night shift operator. And back before we virtualized, we had this server attached to this printer. And the night shift operator, his sole purpose in life was to make sure the printer had paper. And because this was an old process, it was COBOL. Occasionally, it'd come down and we taught the night shift operator just to push the reset button on the server, and everything kind of picked up and everything ran good. So we went ahead and virtualized. And a week later, the printer went down, and the night shift operator, being the well-trained guy that he did, what'd he do? Yeah, he reset the server. So not only did he bring the print server down, he brought our web server down, the database server. He thought, well, we just want to give him the rights to reset the printer server. That's all we want him to do. So we're going to kind of move those over to the side there while we talk about this. vSphere, how you set it up? Again, real easy. What you do is you go to your vCenter, go to Add Roles, give this a role a name. I'm going to call it Reset the Printer. And then it brings up a list of all the rights that you can give this particular role. And I'm going to say, yeah, I really don't want him to turn it off, because in the physical world, when he turned it off, he forgot to turn it off occasionally. Turn it back on occasionally. So I just want him to be able to reset. Don't want to give him access to the console, anything else. I just want him to be able to reset the dang printer. So I do that, and then I go to the guest, select the guest, right-click on it, say Add Permissions. And I select his name's Joe the IT guy. I select his name, and I give him the right to reset the printer. All he has the right to do on this one particular VM is reset the server, that guest. So let's go ahead and see how it's set up in XenServer. So I brought up XenServer, taken a look at it, and they do things just a little bit differently. I right-clicked on the user. Right-clicked on the guest, and it wouldn't let me just select the one guest. I had to select a pool of guests to do it to. And I said, oh, geez, this pool also contains my database server and my web interface and my human resources. But, I got to let him be able to reset the printer. So, this is as fine a granularity as I can give him. So do that. And then I select the rights that I want him to have. And I said, where's the reset printer right? And said, no, you really only have 6 fairly coarse predefined roles that you can give him. And the one that I could find that was closest is this administrative role, the VM administrator. And I was reading the little dialog box there, and it said, he's also going to have access to the console. He can stop this, he can start this, do a lot of other things. And the one that really worried me was the ability to access the console, because if Joe the IT guy gets bored and becomes Joe the hacker, he's going to have not only the availability to stop and start this guy, he's also going to have the console window, and that just worried me a little bit. So that's kind of how you do it in XenServer. And by the way, he needs to be an Active Directory user. Where vSphere, you can actually create a user in vCenter, or they can be in any of the LDAPs we support. We support Active Directory, a few others. But if they're using XenServer, he better be an Active Directory user. So there we go. We get him all set up. So kind of just a quick recap. vSphere, the users can be local or they can be in an LDAP. Really fine granularity. You can let them do exactly what they want to do. And you can choose a single VM. You don't have to give them a pool of VMs. Rich set of primitives lets you select the exact rights you want the user to have. XenServer forces you to use Active Directory, gives you a coarse set of roles that you can give your users. That brings us into resource pools. And like I said, resource pools are going to get real interesting as the clouds kind of become more ubiquitous. So in vSphere, we have a concept of resource pools. And for this example, I'm going to take 5 servers in my data center. And they have CPUs and memory, and they have storage and networking, other things like that. But we're just going to worry about memory and CPU just for simplicity's sake. So I'm going to create a resource pool. And the way in vSphere you can do this is you take your resources, and you create a resource pool. And it does it on a logical layer, which means it combines all the CPU power. In this case, I have 5 servers, each with 4 CPUs, each running 3 gigahertz and 24 gig of RAM. So that's a total of 600 gigahertz, and the memory is about 120 gig of RAM. So it puts these into a logical block. You can take this logical block and subdivide it, pretty much any way you want, by however much memory and CPU power you want to give each one of these resource blocks. And you can go ahead and further subdivide that. And then you can go ahead and assign each one of these resource pools a separate administrator if you want. So it gives you a lot of granularity to choose and do what you want with it. So I took a look at XenServer and Hyper-V. And XenServer and Hyper-V kind of treat things in the same way. There's some slight differences, but for this presentation, they're close enough that we can kind of combine them. And the way they do it is they take their 5 servers here, exact same 5 servers, and they create a resource pool. And the way they do it is on a physical level. So these 5 servers are in a resource pool. And that's fine. And you can take these 5 servers and you can divvy them up any way you want as long as it's on a physical level. So you can take 2 servers and put them in one group, 1 server put in another group, and take another server and put it in finally a third group. It doesn't really let you do the logical abstraction of the resources. And, of course, you can do the administration on a physical level as well. So Hyper-V and XenServer, you can subdivide them on a physical level. vSphere, you can subdivide, allocate, and administrate resources on a logical level. This gives you a lot of flexibility on the way you want to allocate your resources. That's a resource pool. This is... like I said, this is my favorite part of the presentation. And we're going to talk about memory overcommitment with XenServer. XenServer 5.6 came out a while ago, and they said, yep, one of our great features is memory overcommitment, dynamic memory control. And I won't talk about Hyper-V. Hyper-V has something in beta, but we try not to compare against what people have in beta because it's not a fully baked product yet. So we'll talk about XenServer. XenServer does have memory overcommitment, released with 5.6. And this is the blurb that I was reading. I just didn't quite understand it. It said, okay, once the guests are shut down, the memory can be reclaimed and unused on the physical host. And I've been working with vSphere for quite a while, and I just didn't quite understand what they were talking about. So just a quick review. Before, they had overcommitment of memory. You had a certain amount of memory in your servers, and you could allocate that memory any way you want as long as you didn't go over the amount of memory in the physical server itself. So for this example, it was a 24 gig system. I divided it between 3 guests, and it worked out to 8 gig apiece. So that's without memory overcommitment. With memory overcommitment, real easy to adjust in XenServer. You go ahead and go into XenServer, you click on your guest, go into memory, and here's the little dialog. And actually, these sliders are kind of cool. You can either use the sliders to adjust how much memory you want in it, or you can go ahead and key in the amount. They have a minimum amount That's what you guys know as reserve or guaranteed memory. That guest will always have at least that much memory. Then you have the maximum amount. And this is the amount of memory, the most amount of memory you'll ever see on the guest. So this is, if you go into the task manager, that you'll see that it has 8 gig in this case. And so I started playing around with it, and this is kind of what I came up with. So you have your guest here. You start 4 guests. Each guest have 8 gig of memory, so you're actually going into the memory overcommitment. You're overcommitting your memory by 8 gig. And what it does is it goes ahead and puts a balloon in there. That's the first thing it does. It creates this 2 gig balloon in each one of the guests. So the guest itself only sees 6 gig of memory. I thought, well, that's interesting. So I went ahead and started playing around with it a bit. And so, even though the task manager says 8 gig of memory, 2 gig of memory was being used in these guests by something. So I figured out, it's the balloon. So what happens when you run processes on it? I went to the blogs, and the key phrase here is XenServer will only auto-adjust, and auto's the key point here, VM memory to accommodate starting new VMs or manually changing the memory settings. So what this means is it doesn't take into consideration how busy the VMs are or how much RAM they're using. So here's our system again. Here's our guest. We see the balloon there. We have some guests running. And you can see the actual RAM being used there. Then you see this unused RAM because you don't have any processes running on these VMs. So let's go ahead and start a Oracle database in VM01. It tries to go out there and grab as much memory as it can because it likes memory. Oracle likes memory. So when it gets up to the 6 gig limit, it gets no memory. But I was looking at my system and said, but these other guests aren't using their memory. But it didn't grab that unused memory. So it had to shrink back down and fit within that 6 gig size. So you got some wasted memory here. In one of my other jobs, I had to deal with sales folks. And I was talking to this memory guy. He says, Tom, he was trying to sell me memory. He says, Tom, the most expensive memory you have is the memory that you don't have. If you need memory and don't have it, that's real expensive memory. I thought, you know what, he's right. But I'm going to change that just a little bit. The most expensive memory you have is memory that you do have and can't use. That's kind of what XenServer does to you. So I'm going to go back and talk how vSphere does it. We've been doing this for a long time. It's good stuff. And how we really minimize any kind of wasted RAM that you do have. First thing we do is we do a TSP, transparent page sharing. What that does is it goes out there and identifies blocks of data and does deduplication on it. Says, this memory page is being used by various things, and so we're just going to go ahead and consolidate it to one location you guys can pull from it. So that's transparent page sharing. And then when we do get into a situation where we do require more memory in one of the guests, we don't pre-allocate it. So what that does is it pulls it from the pool, and you can use the RAM. But in certain situations, you are going to be into an actual memory overcommitment situation. So you have all your guests running on all cylinders, they're firing there. So the first thing we do is we have balloons in each one of the guests. That's what your VM tools does. And it can inflate the balloon and force the guest to decide which processes are least value and go out to their page swap file. Windows decides this. And that works out very well. It's a very elegant way to do it. Second thing we can do, and this is new in 4.1, we can take memory, and it's called memory compression, and we'll go out there in the real memory and say, this is a holy spot of memory. It has a lot of free space. We can go ahead and consolidate it, and we kind of create a zip file out of this real memory. And, of course, we have to de-zip it, so it's a little bit slower than going out to the actual real memory, in its native format, because we also have to de-encrypt it. But it's a heck of a lot quicker than going out to disk. And that's kind of our method of last resort. You guys want to monitor and make sure this doesn't happen very often. And this is where your systems are just totally bogged down. Ballooning isn't working. Memory compression isn't doing it. And the hypervisor goes out and says, you know what? This isn't working. I need to take a hunk of real memory from the guest. I'll decide what it is and write it out to the hard drive. And that's what your vSwap file's for. So that's how we handle memory management. We have 4 tools to do it. So I wanted to compare this heads to head So I'm going to take vSphere and XenServer. I'm going to run a test on it. My test was there's a program out there called RAM Disk. And what RAM Disk does is it builds a virtual disk or out of the physical RAM in your system. So I said, okay, I'm going to make a 7 gig RAM disk. So I started one guest on vSphere and one guest on XenServer. And it worked fine. Worked on both of them exactly as I thought it would. You can see that the RAM disk started successfully. The green circle, it starts out with very little memory utilization. I start the RAM disk and it ramps up and uses it. I thought, okay, one disk on each system, no problems. So the next thing I wanted to do was start four guests. I'm not running any processes in the other guest. I'm simply starting 4 guests. Remember that little balloon that got started on each one of the guests? The way it does that is it divides the memory equally among the guests. It doesn't really give it a whole lot of thought. It says each guest is going to get 8 gig. I thought, oh, interesting. So I set it to this, started it, and you can see each guest has about 6 gig of memory now. I went ahead and started RAM disk on both of them. vSphere worked pretty much exactly as it did with when I had one guest running on it. Very low memory utilization. You can see in the green box that, yep, the RAM disk started successfully and ran fine. However, XenServer kind of had some issues. The first thing I noticed was that RAM disk didn't start. Second thing I noticed was in that little yellow box there was that you don't have enough memory. I said, no, I got lots of memory on this system. Then I looked at the task manager. Task manager starts out using that 2 gig balloon. It has 8, 2 of it's being used. So when I tried to start the 7 gig RAM disk, no ma'am, failed. So that's comparing vSphere and XenServer, the dynamic memory. So kind of to recap, XenServer, it pre-allocates memory. Can cause you some grief. It doesn't really take into account actual memory usage when allocating the RAM, divides it equally among all the guests. Has only one tool for memory overcommitment, that's the balloon. Where vSphere will allocate RAM on a pre-needed basis. We don't pre-allocate. Has a rich set of tools, has 4 tools to deal with memory and memory overcommitment to make sure it's being used efficiently as possible. And finally, VMware has a proven track record of doing memory management overcommitment right. We've been doing this for a long time. We've learned things as we've gone along and done it. So that's vSphere and XenServer dynamic memory. So kind of in conclusion here, I think Eric did a good job pointing out how easy vSphere is to work with, how easy it is to administrate, how our storage model architecture makes it easy for you guys. And then finally, I pointed out some things in vSphere. Did a head-to-head on a couple different things on resource management. So let me go ahead and bring Eric up here. And by the way, do visit his blog, Be Critical. It does point out some interesting things occasionally.
Great, thanks, Tom. And we'll take some questions if you'd like to step up to the microphone so everybody can hear it. Sorry, that's a little bit of a trip for you, sir.
Yeah, you've mentioned that you do host-based affinity. Do you know if any database vendors are going to be supporting that as a licensing model?
I didn't quite catch that last part. Host-based, are any vendors?
So be able to limit your workloads to only a sub-portion of your cluster to satisfy licensing. Would Oracle support that?
Would Oracle support it? Okay, well, each software vendor is responsible for their own licensing, and whether or not the product, in this case Oracle database, is supported on vSphere is another question, kind of outside of the scope here, but thank you for asking it. We really would like to work closely with all software vendors to get their products fully supported on vSphere. And many customers are running Oracle quite happily on vSphere. And there is a way to get that support. And in fact, if you have I'm sorry to take up more time on this, if you have a problem getting Oracle supported on VMware, you can come up and talk to me afterwards, and I can put you in touch with someone at VMware that might be able to help you. Any other questions? Please step up. We'll be happy to take them. Or Otherwise, thanks a lot for your time. Please remember the surveys are all online this year, so no piece of paper at the back of the room. If you remember, please go online and fill out the survey. And it's great to have you here. I hope you had a great week.
Great. Thank you, guys.